Hi everyone and welcome to activity 24. Today we are going to talk about the law of cosines. Now the law of cosines is going to be used when we are given an oblique triangle. So that's basically our non-right triangles. And we can think about this as just a triangle with angles A, B, and C. Side little a is across from big angle A. It's basically side BC. Little b is the side across from big B. That's side AC. And then little c would be the side across from angle C, aka side AB. And what we're going to see on this with the law of cosines is officially you kind of write it three ways. Like if we're trying to find little a, you would take a squared and then you would take equals b squared plus c squared minus 2 times a times b times the cosine of the angle across from little a, so big A. Now, this could be rewritten differently depending on which angle / side we are trying to find. So, for instance, little b would be by itself. Then you would take the other two sides squared and added together, and then a times c times the cosine of big B. Again, the side across from that angle, or that side, the angle across from the side we were trying to find. Or the third way you're going to see this written is if you're trying to find little c, you would take a squared plus b squared minus 2 times a times b, and then times the cosine of the angle across from the side we're finding, aka c. So you don't need to necessarily know like all three of these. Basically, it's like one standard form each time. It's the side that we are looking for opposite of the angle squared. Because notice like C and C match, B and B, A and A. And then that's going to equal the adjacent side to the angle squared plus the other adjacent side to the angle squared. Angle adjacent side. So side times side squared each, and then minus 2 times those adjacent sides, right side, adjacent side 1 and adjacent side 2, or the other adjacent side if you want to think of it that way, and then all times the cosine of what we call the included angle, right, the angle that's across from the side we're looking for, or in between our two adjacent sides. Now, why are we going to use this, or when, I guess, are we going to use this, the better question, when we are given two different instances, either side, angle in the middle side, and we're looking for the opposite side, or when we're given three sides and we are looking for an angle. So in our first example, this is going to be an example of finding a side given side, angle in the middle there. And you want to make sure that your calculator is in degrees mode. For these, since notice in our triangles we are using degrees, for instance 133. And again, if we are looking for side BC over here, to find that side, we're going to have it squared. You're going to take the two sides surrounding the angle, so 29 and 22 squared, and then subtract away from it 2 times those two sides, side times the cosine then of that angle in between them, the included angle. So that's cosine of 133. So we're going to just type into our calculator then 29 squared plus 22 squared minus 2 times 29 times 22, and then times the cosine of 133. And this value is what x squared is going to equal. So this 2195, all of this is what our x squared equals. So to get our final answer of what just x equals, we are then going to square root that previous answer. So we would get about 46.9 as our final answer for the length of that side. Now, another piece that we can do is we can find an angle. So notice this time in number 2, we are looking for angle B. Notice the side across from angle B is going to be the 21. So that's going to go by itself on this other side of the equal sign. Then the two included angles this time are going to be 9 and 18. And those are going to get plugged in then on the right-hand side of our equation. And then the cosine is going to be of what we're trying to find, angle B. Right? That's our goal, is to find angle B. So first things first, to get angle B as close to by itself as possible, we're going to start by subtracting over these squared pieces. So minus 9 squared minus 18 squared. So we're going to take 21 squared minus 9 squared minus 18 squared, and we get 36. And right now that is equaling this negative 2 times 9 times 18 times the cosine of B, which if we simplify negative 2 times 9 times 18, we have a negative 324 really happening on the outside here, being multiplied times cosine of B. Well, to get that cosine of B by itself, we need to divide over the negative 324. So we would have cosine of B equals 36 divided by negative 324, whatever that answer is. Now to get angle B then fully by itself, remember we are going to use the inverse to find that. So we can just type that fraction in, 36 divided by negative 324, that's the cosine inverse we are trying to find. So 36 divided by negative 324, don't worry about reducing that, your calculator will do it for you. We get about 96.4 degrees for that one. Now, we can also use the law of cosines to help us find an entire triangle. So on this first example, we are given the cosine here, or sorry, a side angle side situation similar to the first one. And so we're going to have to start this off by finding side AB, because that's kind of the piece that we can find since it's side angle side. So we're looking for x squared or AB squared, so that's 21.7 squared plus 25.6 squared minus 2 times 21.7 times 25.6. And then the cosine this time would be of 129.7. So the nice thing about when we find these sides is we kind of are able to just plug these in as is, and then minus 2 times 21.7 times 25.6. Oops, not squared. But times the cosine of 129.7. And again, do not forget on this, you want to make sure that you square root then that answer so that we get 42.8 as our value here for x. Okay, so we know this opposite side over here now is 42.8. Now next we are going to decide then, okay, we can either find angle A or angle B next. I usually like to find the smaller angle first. So I'm going to find angle B. How do I know it's the smaller of the two? Because it's across from the smaller number. 21.7 is smaller than 21 or 25.6. So to find angle B, I need to use the side across from it. It has to go by itself. 21.7 is by itself, and then the included angles 25.6 and 42.8. Those then are on the right hand side. So squared plus squared, and then minus 2 times the two sides, not squared, cosine of, again, angle B, which we're trying to get by itself. So again, step one on these is to subtract over the squareds from what we have on the opposite side. So in this case, I have 21.7 squared. I'm going to subtract away from it 25.6 squared and 42.8 squared. I hit enter, and I get negative 2016.31. And then the next part is we want to make sure we simplify this piece in front of the cosine of B. So negative 2 times 25.6 times 42.8 we get negative 2191.36. And again, that's negative, so make sure we include that. And then that's again times the cosine of b. Well, to get b by itself, again, we are going to end up taking the cosine inverse. We first need to divide away this 21.936. And essentially, that's what we're going to end up taking the cosine inverse of. So to find angle B, again, you need the inverse of this piece divided by this piece. And if we type this in the calculator, cosine inverse of negative 2016.31 divided by negative 2191.36, we get about 23.1 degrees. Now the last part of this, okay, now that we have 2 out of the 3 angles, is we don't have to necessarily do the law of cosines to get our final remaining angle. Remember, angle B, this last angle, there are only 180 degrees in our triangle. We have 2 of them, 129.7 and now the 23.1. So what we can do is subtract all of this from 180 to get that final angle value without necessarily having to do the law of cosines for a third time. So 27.2 would be our final angle value on this one. Now, sometimes we are given the side situation, and then we need to find the angles. So again, I personally like to find the smallest angle first, and I know that that's going to be across from the smallest side. That is the side that is then going to go by itself this time. So we would have each of these pieces minus 2, and then anything that's on this right-hand side stays. Cosine of A, though. Okay, so again, we're going to kick this thing off. We're going to subtract over the adjacent sides squared from our opposite side. And then the piece out front, we would have negative 2 times 21 times 20. And then cosine inverse, the left-hand side divided by that right-hand side. We end up with 48.9 as the measure of angle A. Now again, I like to find then the medium-sized side. So in this case, our medium side will be across from the medium angle. So angle A is the next one I'm going to look to find. And again, you could do this in any order, just personal preference. And then this time my sides would be 21 and 17 that are my included sides. So oops, negative 2 times 21 times 17 times cosine. Oops, sorry, this last one was actually angle C. And then this is now angle A. And then, again, same thing. We're going to start by subtracting over 20 squared minus 21 squared minus 17 squared. Negative 2 times 20 times 17 then in front of our cosine. Cosine inverse of left-hand side divided by right-hand side to give us this angle of about 6. Oops. This should have been 21 times 17. So it should actually be negative 714 that we're dividing by. So be very careful there. So sorry, 714. Now we get that correct answer of 62.5 for angle A. And then last but not least, 180 minus our 2 angles will give us our final answer of 68.6 degrees. So we have all 3 of those angles. Now, the last part of this is a little bit about the setup. Notice how they are giving you the pieces. They have A, B, C would be our angles. Little a means the side across from big A. Little b means the side across from big B. And then little c, it says, is 10. They want you to find angle C. And then in our next picture, another way they might give us these things, again, triangle ABC. Angle C is 50 degrees. Side BC, they're telling us, is 10. And then side AC over here is 9. They want you to find A to B. Thanks, everyone, for watching. We'll definitely work more with these in class.